Yeah, last we did electrodes, right? Then I told you that you had to figure out whether a substance likes to lose electrons or does it like to gain electrons, right? So what you did was you would construct electrodes. And for example, the first type of electrode, like if you have a metal with its aqueous ions, you got sodium and you got sodium ions. Then we know that sodium likes to lose a lot of electrons. Sodium has is easily oxidized. So it's going to lose a lot of electrons. So the metallic electrode over here would have a lot of delocalized electrons and it will build a negative potential. And so sodium would start turning into sodium ions, but up till a certain point. At a certain point, there would be so many electrons that will build up on this electrode that the negative electrons will start attracting the positive ions back. So that's when you have a reversible reaction. But the result is that if something likes to lose electrons, then it will have a very low potential. It's going to have a very negative potential. ठीक है, Varda, is that clear?
Yep, it's clear.
And then we did the other part, which was that if you have a substance that likes to really gain electrons, that was the second type of electrode, gas with aqueous ions. So there'll be gas, there'll be aqueous ions, and then you'll have to put a platinum electrode because you need a charge to build up on something. So you need a platinum electrode in this case because there is no metal. So chlorine likes to gain a lot of electrons. So chlorine would start turning into Cl-1. It will start gaining electrons, the delocalized electrons in the metallic rod, and the metallic electrode will become positively charged. And but up till a certain point, at a certain point, the positive charge becomes so large that it will start pulling electrons back from Cl-1. So that's the point when it will be a reversible reaction. But since chlorine had a very strong tendency to actually gain electrons, which is why a positive potential is going to build up. So a higher potential indicates that the substance likes to gain electrons. ठीक है? तो ये clear है कि a lower potential indicates that it likes to lose electrons, a lot of electrons. A higher potential indicates that it likes to gain a lot of electrons. Is that clear?
Yep, it's clear.
I said then there's going to be a third type of electrode. I mean, which is kind of the same concept, except that the third category of electrodes. What's the third? Just a second. So what's the third type of electrode? It's so the third type of electrode, that's only aqueous ions. So if you only have aqueous ions, now what's going to happen in that case if you just have aqueous ions? And the thing is that sorry, just so if you only have aqueous ions and the reaction is between those aqueous ions. So let's say I've got Fe3 plus ions in a solution, so maybe some sort of salt, and I've got another salt that's got Fe2 plus ions. And I want to figure out this thing. I need to figure out what's going to happen. Does Fe3 plus like to gain one electron to form Fe2 plus? Or is the reverse going to happen? Is Fe2 plus likely to lose electrons to form Fe3 plus? Okay, so I need to figure out whether this reaction goes in the forward direction or goes in the backward direction. So I'm going to set up this electrode. I'm going to just create a mixture of these two ions. And if Fe3 plus likes to gain electrons, then you need an electrode. You need it to gain electrons from somewhere. So यहाँ पे ना, I'm going to add a platinum electrode. And so so this platinum electrode, so all the charge is going to build up on this platinum electrode. If Fe3 plus likes to gain a lot of electrons, then the platinum electrode will become what? Positively charged. Because Fe3 plus would start consuming electrons, right? So you're going to have a positive charge build up. Vice versa, if Fe3 plus likes to lose a lot of electrons, then a lot of electrons will accumulate on the metallic rod, and a negative potential will build up. So whatever happens, the potential will build up on this, and that will tell you what is more likely to happen. So you just have to measure the potential. To measure the potential, you would need so to measure the potential, you would need a voltmeter. ये सेंसर ही बंद हो गया. So to measure the potential, I would just need a voltmeter, and I'm going to connect that voltmeter to a reference point, and I'm going to measure this potential. Okay, that's it. So that's how I'm going to measure, and in this case, actually, a positive potential builds up. The E naught is 0.77 volts, which is positive 0.77 volts. So you're getting a very positive potential. So that means the forward reaction is the one that's more likely to happen. You're going to have Fe3 plus has a higher tendency to actually gain electrons. So you get a forward potential. So if you have only aquascience, this is the type of electrode that you're going to construct. So first thing, drawings, right? All electrodes will fall into three different categories. One is that one of them involves a metal. So if it's a metal with its aquascience, then the metal would be the electrode and the aquascience would be in the solution. If you've got a gas and aquascience, then you have a gas in a gas jar, and you got aquascience, and you would have to insert a platinum electrode. And the third one is, if you have aquascience only and you want to figure out something happening between aquascience only, then you need a platinum electrode to go with it. Okay, you clear?
Yep, it's clear.
So three types of electrodes, right? So now another thing is, what did we learn basically? What we learned was that you got a higher potential. ठीक है, not positive negative, just higher. ठीक है, remember potentials मैंने पहले discuss किया था. It's everything that's measured is measured relative to something, right? So you're measuring heights. It doesn't really matter whether you measure it in centimeters or meters or whatever, right? It doesn't really matter whether you measure the height from sea level or you measure it from your feet, ठीक है, whatever reference point you choose. Whenever you take a measurement, it's always relative. It's always it only tells you one thing, whether it's what's the value compared to something, right? So don't look at the positive and negative signs. It's just high E naught and lower E naught. High E naught indicates that substance likes to gain electrons. It's likely to get reduced. And the lower E naught indicates that it likes to lose electrons. That's it. ठीक है, ये पूरा concept है. ठीक है, is this clear?
Yep, it's clear.
So the next one is something similar. That's an electrochemical cell. Now what's an electrochemical cell? An electrochemical cell is that it will produce, it will convert chemical energy and it will convert it into electrical energy. Okay, that's what it does. An electrochemical cell is when you connect two electrodes together Electricity is going to get produced, but different potentials. Just a second. So when you connect two electrodes together, having different potentials. So these electrodes are also known as half cells. So here's what will happen. Now I'm going to construct an electrochemical cell. For that, what I'll do is I'll pick two electrodes. I'll take this electrode over here. The Fe3 plus. I'm just going to connect two random electrodes together. तो एक ये हो गया. I got the Fe3 plus Fe2 plus electrode, and I'm going to connect it with the chlorine electrode. Let's connect it with the chlorine electrode. So I have these two electrodes. So instead of this chlorine being measured, I'm going to connect both electrodes with each other. ऐसा ये मैंने इसके साथ जोड़ दिया. And I'll have a voltmeter in the middle. So that's my voltmeter. So two electrodes, totally different electrodes. These are हटा देते हैं. अच्छा, totally different electrodes, and they have been joined with each other. ठीक है, ये भी भूल जाते हैं कि this is ठीक है. Let's remove that. So ठीक है, that's about it. अच्छा, so the iron 3 plus electrode has been connected. What was the value of this one? This one had a potential of, it was already calculated, it had a potential of 1.36 volts. ठीक है. So I've got two totally different electrodes and I've joined them together. What is the reaction that's going on over here at the moment? It's chlorine in equilibrium with chloride ions, gaining electrons, losing electrons. And what's the reaction that's happening over here? That's Fe3 plus. Plus one electron. And Fe2 plus. Okay, so you got these two reactions. Now you've got a reaction. First thing that's going to happen is, where would the electrons flow? Outer external circuit mein. Would they flow from the lower to higher potential or higher to lower potential?
Lower to higher.
Okay, so they're going to float from the lower side to in this direction, right? So electrons, so now when you connected two completely different electrodes and you connected them together having different potentials, a current has started. I mean, that's what an electrochemical cell is. That's what your battery does. So you got two different reactions happening, and one of them has a higher potential, so it starts to gain electrons. So the higher potential, the one that's got the higher E naught, the reason it was the high E naught was that it wanted to gain electrons. So in this case, the high E naught is going to start gaining electrons. So your reaction over here will start moving in the forward direction, because electrons will start coming from the other side. So if electrons start coming over here, the equilibrium will automatically shift to the right. TK, you clear that this, so now you don't have a reversible. I mean, this one just starts gaining electrons. I mean, it wanted to gain electrons. Previously, it wasn't getting electrons. But now it's getting a flow of electrons, so it's going to start gaining electrons, right? Is that clear?
Yeah, that's clear.
So, and the reason this was the lower potential was that it wanted to lose electrons. Now the electrons are flowing from this to the other side. So this one has fewer and fewer electrons. So if the electrons become fewer and fewer, the equilibrium will automatically shift to the backward side. So it will start to lose electrons. You just need to know the rule. That is that the lower one, the one that had the lower E naught, is the one that likes to lose electrons. That's it. ठीक है इसको let's इसको highlight भी कर दो. Achha, that's it. So you got a reaction going on. So this is what redox reaction is. This is how you're going to predict a redox reaction. The higher one gains electrons, the lower one loses electrons. So you got this this is the reduction reaction, or the reduction, you can call it the reduction half equation. And that one over here is your oxidation half equation, ठीक है? So you combine the two equations, you end up with the overall reaction. So so add up the half equations, but make sure that the electrons lost and gain are equal. Should be. Its electrons gain and loss should be equal. And you multiply this. So I'm going to multiply this by 2. I mean, it's just for balancing. Otherwise, I mean, the 2 is irrelevant, just making the electrons gain and loss equal, right? So, and you can just add up the reactants, add up the product. So what are my reactants in the first one? It's 2Fe2 plus. What is my reactant over here? It's Cl2. And what are my products? तो इधर क्या product है? That's 2Fe3 plus. And what's my product over here? That's 2Cl minus 1. ठीक है, तो ये हो गया, reaction सारा complete हो गया, ठीक है? Is this clear?
Yeah, it's clear.
And you can also record the E naught cell. The E naught cell is the cell potential, which is basically the potential difference between the two electrodes. So it's referred to as the reduction E naught minus the oxidation E naught, or how do you calculate potential difference? It's higher potential minus lower potential, right? So it's the reduction E naught minus the oxidation E naught. तो यहाँ पे क्या आ रहा है? That's the reduction E naught is 1.36. The higher one minus the oxidation E naught, which is 0.77. क्या value are you? What's the value if you 23 and 36? What 0.59?
Yep, 0.59.
Okay, so you're getting 0.59 volts, right? So we're getting 0.59 volts. So that's your E naught cell. 0.59 volts. Now this value has some significance, and that significance is that if you had a higher potential difference, then the electrons flow would be much faster. But the higher the potential difference, the more current it's going to produce, right? Voltage and your current are directly proportional. So that means a faster reaction will happen. So the bigger the E naught cell, the faster will be is going to be the reaction. Okay. So okay, is this clear?
Yep, it's clear.
So that's basically it. Okay, so you got two electrodes. I mean, all you just need to remember is, I mean, the drawing is important. Labeling the drawing, that's important. The high E naught gains electrons, the lower E naught loses electrons. So that part is pretty easy. Okay, just remember the higher one gains electrons, the lower one loses electrons. You can combine them and you can form the overall reaction. Okay. So there's one thing that's missing, and that one thing is sorry. So that one thing is referred to as a salt bridge. Second. So that's referred to as a salt bridge. So what you have is a channel. I mean, it could be a glass tube that contains ions. Okay, that could contain a solution that's connecting basically the two solutions. The purpose is it could be a filter paper which is soaked in some solution, and that filter paper is kind of creating a channel where ions could flow from right to left or left to right. So it could be anything. It could be a gel. It could be TK. So you got all sorts of different salt bridges. The simplest one is basically just a filter paper that's soaked and it is dipped into on both ends into the solution. TK. Now, whenever you draw the drawing, the salt bridge is like really important because the salt bridge helps to complete the circuit. So the electrochemical cell will not work unless you have a salt bridge. So it completes the circuit. So electrons could flow. Okay, that's the purpose of the salt bridge. Now, the thing is, how does a salt bridge work? So it's very important. Always draw the salt bridge. Okay, but why do we need a salt bridge? The reason we need a salt bridge is okay, what is happening over here? Okay, I told you that the higher potential gains electrons, right? So Cl2 gains electrons to form what? Cl ions, right? Were they clear? I mean, the higher potential gains electrons, right? Is that clear?
Yep, that's clear.
So over time, what will happen is that the solution will have more and more Cl ions because the Cl ions are, I mean, the Cl2 is gaining electrons. So you're going to get more and more Cl ions, TK. Now you need to get rid of these extra Cl ions because they're not needed. They would actually impede the flow of current because electrons, if they come in, electrons are negatively charged, and the Cl ions are also negatively charged. So they're not actually they're going to stop the current. the electrons will not be able to come to this electrode because there would be too many Cl ions which are already negatively charged. Okay? So idea clear है why we need to get rid of the extra Cl ions that are getting produced. Is that clear?
Could you just re-explain the last part, please?
I mean, you get the point, right? The Cl ions are increasing, right?
Yeah.
So if the electrons are coming from left to right, the electrons are coming over here on this electrode, and there's already a lot of negative Cl ions. So the negative Cl ions will repel the negative electrons, right? Is that clear?
Yeah, that's clear.
So basically, while the electrochemical cell is running, the reaction is going in the forward direction. You're getting more and more Cl ions, but you don't need more and more Cl ions because they're going to stop the flow of current. So you need to get rid of those Cl ions. So those Cl ions are automatically continuously removed by the salt bridge. I mean, the amount of Cl ions continues to increase, but at the same time, the Cl ions they diffuse out onto the salt bridge. वो जो filter paper है ना, the Cl ions would, I mean, the soaked filter paper, that is going to absorb the extra Cl ions. So in a way, your salt bridge is completing the circuit. It's because if you had too many Cl ions, the electrons would not be able to flow. ठीक है, clear है? Path.
Yep, it's clear.
So that's the purpose of the salt bridge. Salt bridge kind of maintains the concentration of the ions in the solution. So completes the circuit so electrons could flow. And how does it do that? It maintains the concentration of the ions. So your solution does not become too positive or too negative. So it will try and maintain the ions in the solution. If ions are needed, the ions will diffuse out of the solution. If they're not needed, so that's basically so salt bridge is kind of sustaining the circuit. For example, यहाँ पे क्या होगा कि if the ion concentration decreases, it's going to produce more ions. If it increases, it will remove those ions. So at least the current continues to flow. तो ठीक है वर्दा question ये कि remember there are three types of electrodes, right? Metal, aqueous ions. So the metal is the electrode and aqueous ions in solution. Gas, aqueous ions, you need a platinum electrode. The gas will be in a gas jar. Okay, same concept. And if you have only aqueous ions, then the platinum electrode will be inserted and the aqueous ions will be part of the solution and a potential builds up on the electrode, right? So we're gonna try constructing these. ये भी try करना, ठीक है? Try and so you have to draw the electrochemical cell. And write the overall redox reaction. So my two electrodes are, I've got a copper ion copper electrode, and that's 0.34 volts. Okay, that's the first electrode. The second electrode is a tin 4 plus 2 electrons in equilibrium with, and the E naught, I don't know what the E naught is. I'll just check. Tin copper SN. So it's this one. SN with SN2 plus, that's 0.15. That's a 0.15 volts.
So, for example, for the first one, would it be metal slash aqueous ions?
Yes. I mean, the metal would be
Okay.
the copper metal and aqueous ions in solution. The other one is just
Okay.
the aqueous ions, ठीक है? So, I mean, that's the same, ठीक है? Do everything, do the drawing and find out who's going to gain electrons, who's going to lose electrons, write everything, E naught cell, overall reaction, ठीक है? तो ये अभी कर लो, ठीक है? I'm just on mute. तो
Okay.
ठीक है, I'm just muting here, otherwise I'm available, ठीक है?